Hello, my name is Robert Mitchell, and today Electropages is here in Embedded World 2024 in Nuremberg. And today we are at the TI booth, and I'm joined by Amichai, and it is great to have you here.
Yeah, thank you for inviting me here.
Fantastic.
It's very nice to be here.
Yeah, now, the first question I've got for you, before we get into the details of this boards, could you tell the audience who you are and what you do?
Yeah, sure. So I'm Amichai Ron. I'm a senior vice president in Texas Instruments, responsible for Texas Instruments embedded processing. Basically, TI microcontrollers, TI microprocessors, TI connectivity devices are part of my responsibility.
Fantastic. So I can see a whole bunch of stuff on this board and quite a number of big names.
Yeah.
Could you tell me what's going on?
Yeah, sure. So what we are showing here is basically the scalability of our portfolio. We want to make sure that we enable our customers. Customer wants to see more options. Customer wants to see scalability. So for example, if we look here on the left side, you can see we're offering a microcontroller. If a customer wants to add connectivity to his or her application, we have a connectivity devices. If a customer needs the radar or some sensing opportunities, they can add radar to the microcontroller. So we offer full scalability across our portfolio. The second thing, if you decide that you want a microcontroller, you can also choose a performance level that you need. So we start from a low-end microcontroller, that's an MSP-M0, going to a mid-end microcontroller. Here, this one is focused on a real-time C2000. It's a very big family of devices that allows customers to create real-time application, and going up to an R5-based AM263 device that allow customers to get even higher clock speed, more performance, more capabilities. So very similar software, customer can scale up and down and create the application that they need for the system.
Oh, fantastic. So just to be clear, in terms of the scaling, this would be something for more small size embedded systems, maybe like a low powered IoT device.
Exactly.
Whereas something like here, you might be doing something a bit more beefy, that makes sense.
Exactly.
So what kind of applications could we do with the higher end ones?
Yeah, for the higher end one, so it has a lot of industrial and automotive use cases. So the industrial side, it can do motor control.
Absolutely,
it can do communication between two different machines.
Real-time controls, I suppose.
Exactly. And if you look on the low end, it can do very basic things. So for example, just to blink an LED.
Yeah.
It can sense a temperature and give you a feedback on what's the temperature in the room.
But would I be right in thinking that the energy consumption this would be a lot lower than something like on the higher end?
Exactly. It's a lot lower. Usually it's also a cheaper device and allow customer to build an application based on what we need. I actually have one example here. It's something that we just announced a few weeks ago. You can see what I'm showing here. It looks like a small Mickey Mouse.
What is that?
But that's one very, very small microcontroller. And I remember my old days of working on microcontrollers. There was the size of this board.
I was about to say, they dip through holes.
Yeah, exactly. Now you can see how small the microcontrollers are getting.
Oh my word.
So a customer can, again, they can pick from a very small microcontroller doing some basic thing.
I don't think my cameraman can even focus on it.
No, it's too small. No.
So what's actually going on here then? Because it looks like what is going on here then?
Yeah, so the specific Mickey Mouse, if you can get me the Mickey Mouse with a battery.
Oh, absolutely.
It's just showing one example, as this one also doesn't, but
yeah.
It basically, it has a light sensor here.
Yep.
And if you cover it, it turns the lights on and off. It's just basic use case.
Oh, there's no battery.
So there's no battery here.
No battery.
But that's what it's designed to do.
The point is that tiny little standing up PCB itself has the microcontroller.
Exactly.
And I take it this would be one of the lower end ones, which is good for mass production.
Yes.
Whereas if you're going higher end, obviously the chips get bigger, you've got more I/O. That's absolutely fantastic. So I want to take a look at the millimeter wave radar. So why is millimeter wave becoming so important in modern electronics? Because I'm seeing it appear everywhere.
Yeah, so it's an excellent question. Look, millimeter wave radar, it started almost 100 years ago. For very high end, it used to be $1 million of a system. What we as TI, we introduced to the market the first fully integrated radar chip. It's used a lot in automotive. So when you drive your car, the radar will sense what's going on around your car and will help you not to get yourself into a situation which is dangerous to you. So it's used for safety systems.
Yeah.
What we did over the last few years is to do cheaper and lower power version of our radar. So you can go to a lower end. It can be used as a door sensor. So when you get in front of a door,
I see.
You can open or close the door based on the radar. In the past, we used to do it with a PIR sensor. A PIR sensor can only see if there is a person or there's no person. A radar can also see the direction this person is going. So think about here in Germany. I'm sure the temperature gets pretty low. I'm from Texas, so we don't get as low as Germany. But when you go into a mall, if somebody gets into the mall, the doors open, you lose energy that gets out of the mall because it's hot in the mall and cold outside. You lose energy. Now, if somebody just walk by the door, you don't want the door to open because then you're going to lose a lot of energy. It's not energy efficient.
Right.
So by using a radar, you can detect if this person is going into the mall, if he just crossing the door, and build a very efficient application.
Essentially, you're adding intelligence to that detection ability to a degree, because of fact, like you say, you got more data, so you know that they're not just there; they're walking in that direction. So if they're going that way, there's no way they're ever going to come into the building. So you don't have to open the doors.
Exactly.
So the millimeter wave sensor, is that a separate sensor to the main microcontroller itself?
Actually, in this specific case, it has a millimeter wave sensor. It also has a MCU, or the microcontroller, integrated into the sensor. So from a customer perspective, they can build the whole application with one device. One more thing that is special here, we're showing it as AOP.
Yeah.
It's an antenna on package. So if you look here at the radar chip, actually you get also the antennas on the package. It's a 60 gigahertz frequency.
That's an antenna on the package
actually several
itself.
antennas on the package itself.
Oh, blimey. So that's really interesting. I've got to think this one through now. How do you get the antenna on top of the die?
Yeah, it's an excellent question. First of all, it's a lot of work by excellent engineers in TI.
I know.
But really what's helping us here, the frequency is very high. It's a 60 gigahertz frequency.
Right.
So the wavelength is very short, and you can build very small antenna and put it on the package.
Yeah.
If you go to other frequency, which are lower frequency, you can't really integrate the antenna because it's a much longer.
Much longer one.
Yeah.
But does that mean that you need to expose? It will make the top layer as thin as possible, so the radio waves can get out.
Exactly. You
Not
need
radio,
to be
it's
able
microwave, isn't it? I suppose.
Yeah. You need to design it in a way that it will be exposed.
Right.
And it can sense what's going on around.
And so I take it the material on the top has to be transparent to that.
It's a special material that allows you to get maximum performance, but is also very cost optimized.
Yeah.
So you can use radar in a lot of applications.
It's absolutely fantastic.
So one more area that I want to show you.
Yes.
So I talked about this small microcontroller.
Yep.
That's actually just one microcontroller. To be able to, for a customer to build their application, sometimes they need more memory, sometimes they need a little bit bigger with more IOs.
Yep.
So we offer a very, very scalable portfolio, and I want to share with you the demo here.
Absolutely. So this one over here, is it?
Yeah, it's actually this demo here.
Fantastic. So we've got all these different boards here.
You see the boards here, and actually you can see on the screen a lot of the options of what we are offering to customers.
So they're all the same type of processor, but they're scaling up in ability.
If you look here, you can see the axis.
Yeah.
Show you the number of pins. So you go from.
So that would be your lowest type of device, your very simple devices, as well as this one here. But then going up to here, that's where your performance is increasing.
Exactly.
Yeah.
More performance. You can get more memory, less memory, more IOs, more E2Ds, more analog interfaces.
And I like this one. So you can have like a basic 16-pin part and then go up for more memory, but you don't have to go this way to then end up getting more processing power, which is expensive and has more energy consumption. So it gives you a lot of flexibility to go around here to pick what you want.
Yeah, and what we see also, customer, when they start working on the application, sometimes they don't really know what they need.
Yeah.
I start, for example, with a 32 kilobyte. And then after working on my software, I say, hey, I need a little bit more memory.
Oh God. I'm working on a project right now where we had the exact problem where we were using some other chip, and basically we said, okay, how much memory do you need? I need this much. We designed the whole thing, and he goes, oh, whoopsie daisy, I need another megabyte of RAM. I'm like, oh, we just designed the whole PCB for that.
Exactly. So customer, again, they want to have options. And we are offering a very scalable portfolio.
Yeah.
Now that's just one example of our MSP-M0 portfolio. But we do the same for a microcontroller, we do the same for a microprocessor, we do the same for a radar device. So we want the customer to get to the most cost-optimized, best performance application so they can be successful in the market.
And I think it's also cool that you've got this style of sort of moving around in the types, because if you have a code base, you don't have to change your code when you go to a different device, because it's all part of the same family, but you can go up and across depending on what you need to do.
Exactly. So our customers, the biggest investment they make is on the software side.
Yeah.
So once you start writing your software, you want to be able to move it between applications. You want to be able to move to a higher run application, a lower run application, use the same code. And that's exactly what we are offering with this portfolio.
And so in these four, I think we've got 4 examples here, haven't we? Well, and this is showing different chips in that family.
Yeah. So actually, I have no idea what it's showing. So
No idea. No idea what's
that's
going on.
what,
It's all about this. It's not about
yeah,
this.
it's not about this one. So,
Fantastic. So I also want to quickly turn our attention to one more row, which we haven't actually had a look at, which is this one here. So could you just tell us what's going on with this final row?
yeah. So here we are talking about our processor portfolio.
Which is not the same as microcontrollers. So we're
Yeah.
talking heavier, higher end.
Exactly. So usually a microcontroller will be running a real-time operating system or even no operating system.
Yeah.
A microprocessor will be running a high-level operating system. So it can be Linux, it can be Android. It's running high-level operating system.
Yeah.
And the scalability on the processor side is also a little bit different. We have some customers that want to do an HMI. So they want to do a human-machine interface, basically connect to a screen.
Absolutely.
So we have devices with an accelerator, without an accelerator. AI,
Oh,
I'm
yes.
sure that you hear it a lot here.
That's becoming a massive industry.
So that's
there.
kind of like my number 2 question on every customer meeting after the price. They want to see if we have AI capabilities.
Yeah.
We offer AI, we offer edge AI. So we want to make sure that the customer, for their application, if they figure out they want to add edge AI capabilities, it's part of our scalability. So you can buy a processor, an AM62, just as a basic microprocessor. You can buy the AM62A, which adds the edge AI accelerator and allow you to get more AI performance on your device.
Fantastic. And I suppose, because I'm just sort of comparing your high-end sort of microcontroller to this process here, and you can just see the difference in energy consumption by the fact that this one needs a heatsink and this one doesn't.
It's a different scale.
Massively different scale.
Look, our job is just to enable our customers, okay? Every customer meeting that I had here at the show, it's very interesting to hear how customers are changing the world by creating better and better systems. So lower power, they make it cheaper so more people can buy it. We want to make sure that we enable them. So we offer the scalability.
Yeah.
You can see also on the TI booth, we offer a lot of tools to make sure a customer can get the application started, can go to production very quickly, save time, save money, get their application going. We want to make sure they are enabled, and that's why we are offering this portfolio.
And I think what I'd like to just say about this board that I really like is that because you've got so many different things going on, to me this kind of looks like a complete IoT, what would you call it, like an ecosystem. So you've got like a whole ecosystem. So you've got Bluetooth, Zigbee, you've got your AI, you've got your human wave millimeter detection, you've got your different embedded processors. So I think it's really nice to see this all together. But I just spotted one thing.
And to be fair also, this wall is not big enough.
It's not big enough
to put everything that we are doing.
Devices.
We're just trying to show a few examples, but we have a lot of stuff.
But can I just quickly pick your brains on this? What is going on with satellite here?
Yeah, so satellite millimeter wave, a lot of the cars are moving to a satellite architecture. A satellite architecture, it basically means that the sensor, it's a satellite sensor, so it's not connected directly
like
to the main processor. It's a remote satellite. But still you want to get a lot of data out of the satellite into the main processors that inside the car. So the TI...
And you're using millimeter wave for data transmission?
No, the millimeter wave is used for sensing. So it's still a radar device.
Right.
But it's a satellite. It transfers a lot of data backward to the main microprocessor in the car.
Right, yeah.
And allow you to use edge AI capabilities to be able to detect what's around the car in a more efficient way. And again, TI is the first company to offer a fully integrated satellite radar device, and we are showing it here as part of the show.
Well, that's absolutely fantastic. Now, just before we wrap up this video, I've got one more question for you. Just one more, I promise. For the viewers who are currently watching this video, if they want to get involved with TI's products, what would you recommend they do?
Yeah, so it's an excellent question. We want to make sure that our devices, our software, our tools are very easy to get to. So you just go to ti.com, and you'll get all the information, you'll get all the collateral, you'll get everything that you need to get started, to evaluate the products, and to go to production. And you can actually even order the devices on ti.com and just get everything that you need directly from TI.
Fantastic. Well, thank you ever so much for taking the time to see us today.
Okay, thank you very much.
Thank you.
Thank you.